Sorry, I'm just in time. How are you doing, Rebecca and Sarah?
We're doing well. Thank you very much for the invitation to speak.
Yeah, okay. Well, let's get right to it. So I gave a talk at a Canadian Math Society meeting, and I heard these two women give this phenomenal talk. And I said, I got to convince them to come south of the border, although they're really not, but I've got to convince them to come and share that experience of teacher and teaching assistant. And so I'm so pleased that Rebecca Tyson and Sarah Wyse have agreed to be talking about their climate change material that they've developed and teaching their ordinary differential equations. They're both from the University of British Columbia, Okanagan. And welcome to America.
Thank you very much for that lovely introduction. It's a real pleasure to be here. This is work that we've done in our Introduction to Ordinary Differential Equations course, which is a second-year course at UBC Okanagan, which is in Kelowna, BC. UBC Vancouver is our sister campus. So we're actually a good 4.5 hours drive and 2 mountain passes between us and Vancouver. So we're a distinct university. I'd like to start with my thanks. I managed to get a UBC Sustainability Climate Education grant, and that funded Sarah's work on this project. And then Sarah worked as a TA for the course for 2 years, which was a huge help. So TA support from my department. And then in Canada, we are starting to acknowledge the First Nations that on whose territory we work. So I am going to acknowledge that we are grateful to live and work on the Syilx Okanagan Nation territory. So our goal with this project was to address the aphorism that all models are wrong, but some are useful. And not students can't always understand the difference between a wrong model and a useful model, especially at the second year level. So I wanted students to be able to defend the validity and importance of mathematical climate models coming out of the course. And the way I thought we could do this was to make climate change modeling an important focus of the course. So the format was the following. So all of these components were marked. There's a reflection quiz at the beginning where students think about their knowledge of climate change and the science around it. Then there are several in-person group work projects done during tutorials, which happen weekly. So the climate change group work projects are interspersed with regular tutorials that are just emphasizing work done in the class or material taught in the class. So there were about 7 climate change group work projects. And then I also started inviting climate scientists to come and talk to the class about the topic in a broader way, and then had reflection assignments for these speakers.
So now we're going to go over a couple of the group works that we would do. This is the third of the climate change group works. It looks at what's called the compost bomb and to do with the Jenkinson effect. In this model, our goal was we want to find some climate model that's simple enough for students to understand, but still has some application. One that we found is one that looks at soil temperature with heat gain from soil composting, the carbon in it, either gaining or losing heat from the air, and then looking at how the soil carbon changes over time. So that carbon production, which is pi, is actually a more complicated equation, which we would give separately to them to keep these a bit more simple. And then we have that carbon being respirated out of the soil. And then we let the students investigate these models with a few leading questions to try and guide where they're investigating these things. The first thing we would do is, this was our first group work in the course that had some amount of coding. Most of the students were second years. They didn't have a lot of coding experience. There was a lot of anxiety that would come up with that. So a lot of it was me going, you don't need to know how to code. You just need to find the run button and press it. If something goes wrong, let me know. I'll help you work through it. But we still did want them to read the code a little bit so that they could work with it a bit. So what we did is we made a couple errors in the model. This isn't coding errors. This is, for example, this alpha, which is highlighted right there, we just didn't include it in their code. They had to go type in the word alpha, make sure it was multiplying correctly, and then the code would run properly for them. We had one other error, but it's not listed here, and I don't know it off the top of my head.
But it was similar.
But it's a similar one where we've changed one of the parameters, we've made the model look different. They just had to look at the model equations here, compare it to the equations they had in the code, make sure they look the same. After they do that, we get them to investigate a few different initial conditions. This is something where I would actually show them, hey, if you press run, this is the first one you should see. If you don't see this, let me know and I'll make sure you've actually fixed the right errors in code and then make sure your code's working, because we don't want to send them through the whole investigation with the wrong model or the wrong code. So it was a bit of hand holding to be like, it's okay, you don't need to learn how to code. We just want you to press run. This first initial condition, we have a low temperature, so 1 degree Celsius, and I can't remember what carbon had units of, but 12 for carbon. And we see that both the temperature and the carbon are going towards towards a steady state there with different initial conditions. So higher temperature, lower carbon, we still see it going towards that same steady state. In the last case, we have to get them to change the windows and make much larger windows on that y-axis because we see the compost bomb happening here. So we see a sudden decrease in the carbon in the soil as it's all being respirated out. And when that happens, we also see a very large increase in the temperature of the soil. And this is what is called the compost bomb. It's what we wanted them to look at and try to find within this investigation. Following them seeing, okay, initial conditions make a difference. When we have different initial conditions, we could see different model behavior. We wanted them to investigate, okay, what effect did the initial conditions have? Where did you see this compost bomb? Why might this effect have occurred? And then we wanted them to make a hypothesis and go, okay, we think this happened because of this, and then run additional simulations to test that. With this one, it was a bit harder to mark. In the solutions I would write, if the answer sounds reasonable and like they thought about it, give them marks, because we just wanted them to investigate and look into these things further and study them more. One of the groups thought that, okay, maybe with higher carbon, then the compost bomb is more likely. So they tried increasing the carbon and found that there's a certain amount of carbon where the compost bomb just doesn't happen if you go above it. And that was something that surprised them, where they weren't expecting it in the model. But through this investigation, they were able to find something result they didn't expect and investigate it further. And I believe that is the compost bomb group work. We have one more group work to look at. This tends to be the class favorite. It uses En-ROADS, which is an online climate simulator. It's for educational purposes. En-ROADS stands for the Educational Rapid Overview and Decision Support. Overall, it's a climate model. It has a whole bunch of sliders, and then moving these sliders let us investigate different climate scenarios. The really cool thing with this model is it looks very simple. I've used it with middle school students and they still got a lot out of it and were able to understand it. But if you want to know more, under the simulation tab online, it shows you all of the model assumptions. It shows you how they've created this model, and you're actually able to also look under the hood and see what's going on. Some of the questions we used in this group work were what combination of the sliders keeps the temperature change below that 1.5 degrees Celsius in our Paris Agreement, and then what temperature change is predicted by the settings they chose. We want them to just move around the sliders, make a guess, see what happens as they change these sliders. Other similar ones where we wanted to move the sliders, we're looking for the best case climate scenario or the worst case climate scenario. The main goal is try out using this model, see what happens, what are the results that we see. A further investigation with this one is, I'll go back to this page for a moment. At the top, there's this graphs tab. Under graphs, there's a whole bunch more graphs. So this one just looks at our net emissions and temperature. A different one that we could look at is land at risk of flooding by the year 2100. So I believe this one is set up for the best case scenario when I took this screenshot. Everywhere in blue is land at risk of flooding based on their model predictions, and the little areas in green, so here between Quitlam and the Golden Ears Park, is the land saved by those actions. So this is one, being our sister campus is UBC Vancouver. It's right in this region, it's up on a cliff, it's safe, but we can see for students who are in the Okanagan, they're familiar with Vancouver, and they're able to see, here's a place they know that might be at risk of flooding if our climate doesn't improve, if we don't do enough to work against climate change. And if that was what our group works were, things that worked is students investigating these applications. There were a lot of really cool conversations that I got to hear in tutorials of just students talking about what they knew previously, what they were learning from the lab, and investigating the model we had. And it's also an introduction to math modeling and research that most undergrads don't end up getting during their math courses. It's a lot of, do these steps, here's how you solve the equation. This was a way to show them, hey, here's what research might look like if you go into math modeling.
I'd just like to add that these group works are all designed to fit in with the course materials. So the compost bomb, I have a little section in the course where I talk about numerical analysis of ordinary differential equations. And then, of course, we do linear second order ODEs. So that's the link, and they get a chance to see some numerical implementation, and they get a chance to see a non-linear second order ODE system. The En-ROADS model has a dynamical system under the hood. So before we get to the En-ROADS model, we talk about compartmental modeling. And so that is a link into the En-ROADS assignment. In the course, so Sarah was doing the tutorials, I was teaching the lectures. And so I was in charge of the climate reflection assignments. And I found that went quite well. The students really liked it, and they enjoyed it when I responded in the following lecture. And then I had quite a number of students thank me for putting climate change content in the course. There were some issues that arose.
Because they always do. So in the group work I mentioned when I was talking about the compost bomb, it's our first one that has coding. And when students don't have a coding background, it really scares them when you say, hey, we're going to do coding, good luck. So it was a lot of me going, we're okay. Can you see the run button? Can you press it? Good. That's what we need to do. And that was a way to help them. And there was a lot of, okay, here's the steps. If you follow the steps, you'll be fine. If you don't feel like you're fine, I'm here to help. The other thing was there wasn't a lot of time for students to think about applications and models. So in terms of, we would get student evaluations at the end, and I do remember seeing some comments of they wish they had more time because it's 50 minutes and to learn a new model, relate it to course content, but then also investigate the model and think about climate change applications. 50 minutes is not a lot of time to do that. And a lot of students wanted more time to really get into and investigate these models more.
Yeah, so I'm trying to address that second one in the course by giving them a preview of the group work in class, tell them what it's about, so that when they get to the group work, they're hitting the ground running. We're also refining the group work assignments to handle some of these issues, to hopefully get them to the meat of the material faster. In the class, one of the things I ran into in a pretty big way was climate anxiety, and I really do not feel like I have the training or tools to deal with that. So I essentially, since then, have changed the climate reflection questions so that there's less of an invitation to express climate anxiety, which is not necessarily the way I would like to go. So once I find somebody who can help me with that aspect, then I can put those questions back in. But for the moment, I didn't want to invite the kind of problems I didn't know how to deal with. And then with the invited speakers, because I don't always know what they're going to be talking about, the students didn't always see the connection to the course. So finding the right speaker and making sure the speakers know how to link the material to the course content is another issue. Moving forward, we're going to be continuing to refine the projects that exist. And thanks to Brian's feedback, we're also going to be publishing this. That's on the list of things to do. And we'd like to make the group works freely available. There's more integration of the climate change group work content into the lecture. I'm working on that, trying to figure out what works for the students. And then there is a big collaborative project going on at our sister campus in Vancouver with math and Earth, Ocean, and Atmospheric Sciences. That's one department. Together, they're collaborating to improve climate education at UBC in math courses. So we're involved in that and looking forward to including some of that material in what we're doing. Oh, and that's an extra slide. Yeah. So that's our presentation.
Our internet connection.
Yeah, we can't hear you, Brian. You're muted.
I think we lost. No, maybe we lost. Maybe I lost the sound, but no, it's okay. Victoria has a question, if that's okay.
Absolutely.
Well, this is, thank you for the great talk and the wonderful ideas. I liked your presentation a lot. I was wondering if you have a slide with some references. I would be happy to borrow your compost bomb model, but parameters for the system of equations would be helpful to have. You have some references for 2010 paper on the slide.
I don't think we have a slide for that, but if you send us an email, we'd be happy to send you everything we have.
Yeah. The Jenkinson effect and the compost bomb is based on one specific paper. I do not remember the authors off the top of my head,
but one of them.
Yeah,
I know. It is on the slide. I will try to find it out. And
yeah, you certainly, if you type in compost bomb Jenkinson effect, I think you'd find it. Yeah.
Most of the parameters in it are the typical climate parameters, where if you search up stuff like heat capacity, that's not one that's in it, but that's the one off the top of my head. Like the Stefan Boltzmann constant is one of the parameters in there. So a lot of them you'll find them in any model, but it's just what letter did we use for them?
Anyway, we're more than happy to send what we have to anybody who writes. Yeah. Another question? Yeah.
Yeah. The anxiety about technology. I loved what Sarah said, where you have to push the button. I appreciate that. And I also like the little deception you put in by maybe leaving a little something out in the code, something that maybe is obvious, because that says they have to look at the line and look at it and say, oh, I see, oh, I don't see. Coding can be very frustrating. And when I started using Maple on VAX machines, I just assumed that students would be able to figure it all out. And it's just not the case. When I was at West Point, I had a young male cadet who came to my office because I told him he was just disruptive in class. I can't do this. We were using Mathematica. We sat down in 20 minutes, one-on-one. I was able to calm him down. He was literally very emotional. 3 years later, knock on the door. He's the senior. He works in the tutoring center. He goes, I want you to know I'm the Mathematica expert. So,
That's a great story.
you just have to work slowly, but the way you're doing it is good because the first taste is a good one. They get to see it all. And then using software that doesn't require coding, like the En-ROADS, allows them to play. And so I think that's a nice mix.
And that was a lot of our goal. Is we used to have more coding in the first year classes, but I don't think it's being used much anymore. So the second year classes are when they first see coding. So us providing the code was our way of going, you can code this, but you don't have to know how to do it yet.
Yeah. So how do you get your speakers? Rebecca was talking about maybe once we get them, try to correlate well with the course. But how did you get initially speakers? Do you go to the Kiwanis Rotary Club, or how do you do this?
So UBC has asked faculty and postdocs, researchers at the university, if they would be interested in volunteering as climate experts in the classroom. So there's a list of people who have put up their hands and said, yeah, I could give a climate talk in the classroom. And so if you put a request in to this, I don't know where it goes somewhere. There's there's an office that's running this. So you put a request in and they send it out to the volunteers, and hopefully there's a match. And so you don't know who you're getting, which was, and actually I did have a few conversations with the speaker beforehand to try and figure out how to make it fit in with the class. And his talk was good. But I'm, as I learn, I think I would give him more direction next time.
For students having not seen many talks,
right?
They also aren't prepared for what a math talk or a research talk even looks like, I would assume as well.
Yeah. So that was the climate scientist. And then the second talk, I invited somebody from the city to talk about adaptation. And the idea about that was to present it as so the climate talk can be a bit of a doom and gloom, and then the adaptation can be, well, what are we doing to try and cope? So I hoped that would be a more positive experience. But that was about Kelowna, and it turns out the students weren't all from Kelowna, which is where our university is, and so they weren't sure how to plug into it. So that was my experience. I mean, I think lots of students did found value in those talks, but there's room for improvement. So where would I go next? I mean, ideally, I think I'd like to pick particular faculty and see if they'd be willing to give a talk. But of course, finding them can be tricky.
Yeah.
So I'll acknowledge that.
I just wanted to volunteer that every school I've ever taught at since 1971, I volunteered to be the seminar or speaker chair. And I did that selfishly because then I'd go to the airport and pick you up, and I would have dinner with you, and I would talk with you, and I would learn about this stuff more than anyone else on the faculty, okay?
Yeah.
Plus, I would make a friend. But I have never, ever been turned down by someone who I invited.
Nice.
At West Point, when you got invited and gave a talk, we would give an honorarium. And because it was West Point and it was history, many of the people turned down the honorarium. They accepted the and the superintendent would write them a letter that would say, greetings, thank you for your service. And most young men, when they got a letter that said greetings, it was usually a draft notice. And so most of the visiting faculty that I had come talk framed that letter, and it's in their office. But I did want to point out that people in industry are pleased to be invited. Now you have this issue of, are they going to be like this and miss the experience? But you can also have them give a little personal, take some time to talk about their career paths. Because, we always talk math majors, and of course, we all want them to be math teachers and everything. And yet, in fact, there's all these other things. I had a chemist from Lilly, Upjohn company, and I wanted him to come over and give a talk. And, sometimes you have a seminar and you don't have other people show up and you're embarrassed and, all these kinds of things. So I had this guy and he said, well, I can't come over unless I could bring along a computer scientist. And I went, uh-oh. And he said, and we'll need 2 hours of time. And I'm going, oh, man, I can't get people for 45 minutes. And so I said, well, could you do that? No, we'll need 2 hours. And so I said, okay. And so I invited them over. We had 60 faculty and
Oh,
students.
wow.
I got the chemist, the biologist. I learned what the word pharmacokinetics meant. And they gave an interactive where the students and the faculty were modeling. So sometimes when speakers, potential speakers come back with you and say, yeah, but sometimes those buts are worth listening to. I had another guy come back and his job at Connecticut General Insurance was to set the premium for General Motors dental insurance. How much should we charge General Motors for dental insurance? Think about that problem. Right away, it's just staggering problem. And so outside speakers really can enrich it. And even if they miss the mark, there's something that students are going to listen to. And it could be just some small anecdote that go, yeah, I didn't realize they used math. That's all, so.
Right. Yeah. Nice.
Yeah. Before I monopolize everything, any other questions or time?
There might be things in the chat.
Yeah, I had a question. My chat thing is good. I can't figure out how to get it back, but I'd love to do something similar at my institution. One of the reasons is I see these opportunities for grants for funding and sustainability every now and then. And I think, oh, if I could just come up with a good idea. And so this is very helpful for me. I guess when you're setting, do students they know they're signing up for this when they register for the course? Is this like a special topic?
Nope.
Yeah.
It's a surprise.
It's it's a second order ordinary differential equations course. It's a required course across a bunch of degrees, which was part of my argument when I applied for money. I said, one of the important things about trying to include this material in second year is that I can reach students in a whole bunch of different fields and reach them early and get them thinking about this stuff early in their academic career. So that's why it's in the group work, and it's a thread through the course, but it's not in the course description or anything like that.
Yeah, I could see how that would work, where as long as you cover all the topics and learning objectives.
Exactly.
It's just pick different applications then.
Right.
And the goal with this was we had the list of here's the learning objectives. Now, how can we find models that fit into these learning objectives? So it was a lot of figuring out what ones can we use and then fitting the models into what we need to teach in the course.
Yeah, that was a big challenge.
Yeah.
And I like it, at least it sounds to me like I wouldn't have to be an expert in.
No.
Right. Yeah, because I couldn't answer if techno, but as long as I understand how the equations work and the relationships, be fine, right?
Right.
And there's been a lot that I've learned from the students where they'll be having their own discussions and I'm like, oh, that's something I didn't know before, because they have so much knowledge themselves that even just listening to what they talk about is very enlightening.
Yeah, I'm going to have to leave because I'm working in the next session, but keep talking. And thank you very, very much, Rebecca and Sarah. We really appreciated your sharing with us. Okay, so don't let me stop you. Okay.
Okay. Thank you very much. Victoria, your hand's up again.
Accidentally, that was me trying to clap.
Okay, I've done that before too. Thank you.
And
Pushpi has raised his hand.
I wanted to thank you, and it was great.
Hand. I apologize.
I'm already typing a email to ask for material.
Oh, absolutely.
Yeah.
Absolutely. Do you put that in the chat or here? I think we're supposed to put our email.
I
Okay.
think found your email. Yeah, okay.
and
Yeah.
I think our emails might be part of in the Zoom.
Oh, they might be part of
I
that.
think they might be in there.
Yeah,
already.
feel
I'm
free to
not
write
sure.
us.
Google searched. Yeah.
Super.
Okay.
Yeah.
Any other questions?
Because I think
I probably will ask again if I can. So, in terms of assignments, how many, I do not know, projects or how you plan it for the semester?
Right.
Do within-
So there's quite a bit of, yeah. So I have the regular assignments that are due every week, except in test weeks, on the regular course content. And then in addition, there are these group work assignments that are done during tutorials. So they have to be there in person. So I allow them to drop, I think, the two lowest. Because sometimes you're sick or sometimes the traffic doesn't work and you can't make it. But the idea is that they do it during tutorial.
their groups.
We mark those quite leniently. So the assignments are marked in the usual way, but the group work, climate change assignments are marked quite leniently. As long as they're engaging with the material and thinking about it, they get full
Yeah.
marks.
A lot of the answer key is if it's thoughtful, give full marks because we don't want them to lose marks for not having as much knowledge ahead of time.
Right. And then some of that group work material can appear on tests. So that's the other incentive for actually engaging.
Half of the group works are based on regular course content without the climate change, and then the other half are the climate change ones.
Right. Yeah.
I believe there's 12 total, six and six.
Right. Thanks so much for all the compliments. But we've noticed there's another email though, so Beverly will send you our material.
Thank you, Beverly, for requesting materials. Thank you, ladies, for their wonderful talk. Was good to meet you.
Likewise.
Right.
And if you have any ideas, please send them back.
Sure.
Super. Thank you.